If the radius of the earth contracts to half of its present value without change in its mass, the new duration of the day will be. Okay, so to solve this problem we have to apply concept of law of conservation of angular momentum. Okay, so according to law of conservation of angular momentum, initial angular momentum is equals to final angular momentum. Okay, so I1 omega 1 is equals to I2 omega 2. So here radius of the earth contracts, it means decreases to half of its present value. So initial radius is, let us say initial radius is equal to r. Okay na? Now final radius r2 is equals to, so radius decreased or contracts to half of its present value, so it will becomes r by 2. So initial radius of the earth is r and final radius r by 2. Okay, half of its present value means r by 2. So we know that generally we consider shape of earth as spherical. In case of spherical body, moment of inertia I is equals to 2 by 5 mr square. Okay, so moment of inertia formula for spherical object is 2 by 5 mr square. Okay, so here we have I1 omega 1 is equal to I2 omega 2. So here we have to find new duration of day. So new duration of day means time period. We need time period T2. Generally, what is the time period of one day? T1 is equals to 24 hours. Okay, fine. Now, moment of inertia I1. I1 means 2 by 5 m1 r1 square omega 1 is equal to I2 2 by 5 m2 r2 square omega 2. In this question given there is no change in its mass. See, without changing its mass, so here mass is constant, there is no change in mass, so m1 is equals to m2, so cancel out m1 m2 and 2 by 5 get cancelled. r1 square, r1 how much? r1 is equal to r, initial radius of the earth is r square into omega 1. So here omega means angular velocity. What is the relation between angular velocity and time period? Omega is equal to 2 pi by t. Omega is equal to 2 pi by t. Let us apply this formula here. Now r square, omega 1 means 2 pi by t is equal to r2. So final radius is r by 2. So r by 2 whole square into omega 2. So 2 pi by t1, here 2 pi by t2. Okay, r square into 2 pi cancel, 1 by t1 is equal to r square by r by 2 whole square means r square by 2 square. 2 square value is 4 into 1 by t2. Now r square cancel. We will get 1 by t1 is equal to 1 by 4 t2. Now transpose 4 from RHS to LHS. Division becomes multiplication. So 1 by T2 is equals to 4 by T1. So 4 by, so what is the value of T1? T1 is equals to 24 hours. 4 1s are and 4 6s are. Now 1 by T2 is equals to 1 by 6. Now take reciprocal on both sides. We need T2 value. Now T2 is equal to what? 6 hours. Therefore, new time duration will be how much? 6 hours. If the radius of the earth shrinks by 25%, here shrinks means reduces by 25% without change in its mass, the time duration of one day will be. So here initial, let us consider initial radius r1 is equals to r. So here earth radius shrinks by 25%. How much? 25%. So r2 will be 100% minus 25% into r, initial radius. So how much? 175% of r. So 75% means 75 by 100 into r. So 25 threes and 25 fours. So final radius is 2 by 4 into r. R2 is equal to 2 by 4 into r. Okay. So without change in its mass, so initial mass of earth is equal to final mass, m1 is equals to m2. So we have to find time duration. So here time duration means we have to find t2. And what about t1? So t1 means time period for 1 day. T1 is equals time period for 1 day, how much? 24 hours, approximately 24 hours. Okay. So to solve this problem, we have to apply law of conservation of angular momentum. So according to law of conservation of angular momentum, I1 omega 1 is equals to I2 omega 2. Okay, I1 omega 1 is equals to I2 omega 2. Now, so I1 I1 means moment of inertia of earth. So moment of inertia of earth is what? So generally we consider shape of earth is spherical. So moment of inertia of spherical objects is 2 by 5 mr square. Okay. So I1 means 2 by 5 m1 r1 square into omega 1 is equals to 2 by 5 m2 r2 square into omega 2. Now 2 by 5 cancel. Here there is no change in its there is no change in mass of the earth, so m1 m2 get cancelled. So r1 initial radius is r, so r square omega 1. So omega 1 is equals to 2 pi by t1. Okay. So angular velocity is equals to 2 pi by time period, 2 pi by t. So this formula is very important. Omega is equals to 2 pi by t. So apply this formula. Now R2 how much? 3 by 4 into r whole square into omega 2 means 2 pi by t2. 2 pi cancel. R square by t1 is equals to here 3 square 9, 4 square 16 r square, okay, into 1 by t2. R square get cancelled. Now we end up with 1 by t1 is equals to 9 by 16 t2. 9 by 16 t2. Now transpose 16 t2 to right hand side and t1 to left hand side and t1 to right hand side. So just do crosswise multiplication. So 16 t2 is equals to 9 t1. We need value of t2. So transpose 16 t2 is equals to 9 t1 by 16. So t1 how much? 24 hours. 9 into 24 by 16. So 8 2s are 8 3s are 9 3s are 27. 27 by 2. If you simplify further, you will get 27 by 2 how much? See, t2 is equals to 13.5 hours. So new time duration will be 13.5 hours. A particle of mass m is moving along a circle of radius r. So there is a particle of mass m and this particle moving along a circle of radius r. Radius of this circle is r. A time period t. With a time period t, its angular momentum is. So we need L. Relation for L. We know that relation between angular momentum and linear momentum is given by L is equal to R into P. So here L is angular momentum, R is radius of the circle and P is linear momentum. Again we have one more formula for linear momentum. Linear momentum P is equal to mass into velocity. So L is equal to R into M into V. Okay. Now L is equals to R into M into V. V means linear velocity. So linear velocity of particle is equals to r into angular velocity. Now r into r square into m into omega. So here we have time period t. What is the relation between omega and time period? We know that angular velocity is equals to 2 pi by time period t. Okay. So here time period means time taken to complete one complete revolution, full revolution. So anyhow here omega is equal to 2 pi by t. Put omega equal to 2 pi by t here. You will get r square into m into omega. So omega value 2 pi by t. Now angular momentum L is equals to 2 pi m r square by t. Okay na? So this is the formula for angular momentum of a particle in terms of time period and radius of the circle. Two particles of mass m and 2m are revolving along different radii in the ratio of 2:3, whose time periods are in the ratio 2:3. The ratio of their angular momentum is. So we need ratio of angular momentum means L1 by L2. L1 by L2. Okay. So here we have to apply law of conservation of angular momentum concept. Okay. So we know that angular momentum formula L is equal to I omega. L is equal to I omega. So L1 is equal to what? I1 omega 1. I1 omega 1. Similarly, L2 is equal to I2 omega 2. L2 is equal to I2 omega 2. Now ratio L1 by L2 is equal to I1 omega 1 by I2 omega 2. Here I means moment of inertia, omega means angular velocity. Omega means angular velocity. Now, what is the moment of inertia formula? M1 R1 square. Omega 1 by M2 R2 square into omega 2. We know that angular velocity omega is equals to 2 pi by time period. Angular velocity is equal to 2 pi by time period t. Now m1 r1 square, omega means 2 pi by t1, omega 1 means 2 pi by t1. Similarly omega 2 means m2 r2 square into 2 pi by t2. So now substitute the values. L1 by L2 is equal to m1 means how much? So m1 is equal to m mass of particle 1 into r1 square. Here 2 pi cancel. So m into r1 square into 1 by t1 whole divided by m2. M2 how much? 2m. 2m into r2 square into 1 by t2. Now mm cancel. 1 by 2 into r1 by r1 square by r2 square can be written as r1 by r2 whole square. 1 by t1, 1 by t2. So it can be written, take reciprocal. So 1 by t1 by 1 by t2 means t2 by t1. Okay. Now L1 by L2 is equals to 1 by 2 r1 by r2. Ratio of the radii is already given 2:3. So 2 by 3 whole square into t2 by t1 can be written as 1 by t1 by t2. Now 1 by 2. 2 square 4, 3 square 9 into 1 by t1 by t2. Ratio of time periods also given 2 by 3. Okay, here 2 1s and 2 2s. Is equal to 2 by 9 into, so 2 by 3 can be written as 1 by 2 by 3 means 3 by 2. 3 1s and 3 3s. 2 1 2 1s. You will get 1 by 3 or 1:3. Therefore ratio of angular momentums is 1:3. The angular momentum of a body changes by 60 kg meter square second power minus 2 when its angular velocity changes from 10 radians per second to 30 radians per second. Find the change in its kinetic energy of rotation. Okay, we have to apply concept of angular momentum. So change in kinetic energy of rotation, change in kinetic energy of rotation is equal to 1 by 2 I omega 2 square minus 1 by 2 I omega 1 square. So it means final kinetic energy of rotation minus initial kinetic energy of rotation. Then we will get change in kinetic energy of rotation. Here let us take 1 by 2 and I common. So here 1 by 2I, here 1 by 2I common. Take out 1 by 2I. I means moment of inertia. Okay. So we have omega 2 square minus omega 1 square. Now this is like a square minus b square. So what is the formula? A plus b into a minus b. A plus b into a minus b. Okay. So 1 by 2 into I means I by 2. I by 2 omega 2 plus omega 1 into omega 2 minus omega 1. Next. Here we have a formula for angular momentum. L is equal to I omega. So formula for angular momentum is L is equal to I omega. So for change in angular momentum, delta L is equal to I into delta omega. Delta L is equal to I into delta omega. So delta omega means here what is delta omega? Change in angular velocity. Omega 2 minus omega 1. Okay, omega 2 minus omega 1. Now, so here we have I by 2 into omega 2 plus omega 1 into omega 2 minus omega 1. So in place of I into omega 2 minus omega 1, we can write delta L. Then change in kinetic energy delta Ke is equal to 1 by 2 into delta L into omega 2 plus omega 1. Omega 2 plus omega 1. Now substitute all values. 1 by 2. So here already given change in angular momentum. How much? 60 into omega 2. Omega 2 is how much? 30 radians per second. Omega 1 10 radians per second. Now simplify further. 2 ones, 2 30s. 30 into 30 plus 40. Sorry, 30 plus 10, 40. 30 into 40, 1200 joules. Therefore, change in rotational kinetic energy is 1200 joules. So final answer is 1200 joules.